Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is another b2600. Now this one has a missing screw over here, and this little bracket over here is damaged. I'm not sure if this was done during shipping or during removal. I could be both, although it was packed pretty well. I wouldn't expect this to happen during shipping, especially since you need pretty significant force to bend this. As you can see, it's not that easy to get it straight again because it's pretty strong steel. But looking good now, more or less. I think this is also bent, but I'm not sure. No, this is supposed to be a little bent. Alright, let's see what's inside and what we can do over here. Let's hope there's not too much damage and we can just recap it and be done. But if there is, then we have to properly restore it. Oh my god. What the... Are you kidding me? What is this? What is this here? Jesus Christ. This will not be easy. Alright, so what we see here are the wires going directly to the harness. Questionable soldering, very inadequate wire. This one as well. These are like really thick steel wires. You should use copper, regular copper, thin copper wires. You don't need a huge wire like this. And I'm not sure what is the deal with all this. The caps haven't been replaced. This one hasn't been replaced, but usually this one doesn't give you a lot of issues. This one does. And I don't see much corrosion. Is this the original cap? No, I think originally they come a little thinner. I think this was replaced. Damn. That's not what I was hoping for. I was hoping for an easy repair, but this will take hours to get this straightened out. Corrosion has not been cleaned. We have plenty of green copper everywhere, especially here. So this was not done properly. That's the worst part. You know, I don't mind when the ECMs are in really bad condition when I get them. Right, half of the traces are corroded and that kind of stuff. Yeah, it's a pain. But at least, I don't know, it is what it is. But in this case, I'm not sure why we have this cap over here. Normally it's not installed, and I think this one is normally not installed either. Why are we going here? What is up with this wire all the way to this resistor over here? So we have like a bypass over here. I'm not sure this is what it's supposed to be. Let's see the other side of the board. Maybe the other side will explain why we have this much wiring on this side. Maybe the traces on the other side have been completely either corroded through, or maybe there was some kind of damage to the ECM. But this is definitely the worst one I've done so far. And nothing's been cleaned over here either. The soldering, oh my god, look at this soldering. Yeah, so this was definitely done inadequately. Yeah, look at this solder joint. So clearly, well, you can see here, see this? Yeah, so that's clearly, I don't know, maybe, you know, sometimes when older technicians do stuff like that, you know, they know how to solder. They have proper, you know, flux and stuff, but their eyes are just not what they used to be. So they just can't see, right? And they don't have proper equipment like microscopes and stuff. So, you know, technically, I think this will work. This did work most likely. But yeah, some of them, like this one, doesn't look too bad. I'm not sure if this one was replaced or not. Over here also doesn't look perfect, but it's okay at least. Oh, and the conformal coating was not removed before soldering. So yeah, this is crap. Looks like there was some flux, but this looks like the flux that just flown out of the solder, right? The rosin core. And that's most likely what it is. Yeah, and here as well. Yeah, this is most likely just the resin from the flux. But here, look, this is pretty nicely done. So you can do well. You just, I don't know, probably I would blame old eyes or something, or just negligence. Didn't check. It does not explain why we have this wire over here though. And it doesn't explain why would you not remove the corrosion. Look at all this green copper, all that needs to be neutralized. You can't just leave that as is, or else it's just gonna start corroding again. This via should be restored. Yeah, this via, look, you see, typically that happens. That via typically gets corroded, and usually this diode also needs to be replaced. But this one looks good, and yeah, this should be good. But the via, judging by the look, I would expect it to be not working. So that's gonna give you issues. But over here, this trace, look, they all look pretty good. There's not much damage to the board. I really don't know why these wires were connected here. And what is this wire doing? What is it for? Where does it connect? Why is it not insulated? You really, oh, maybe because this trace is gone. It looks like it's gone. So that's probably why. Yeah, it would make sense because it looks like the trace is gone over here. But why would you use huge steel freaking wire? And why would you solder it onto the harness directly? What is this? And leaving this huge unprotected wire, no insulation. Crazy. Same here. Why would it go to here, to the diode? Is it also because, yeah, it doesn't make sense. These wires don't make sense to me. Okay, let's do this. First, we're gonna remove the cap, the main cap that usually gives us issues, right? And let's check underneath and see what's up. So this is the cap, and let's do 375. So this should be lead-free solder, or sorry, the leaded solder. So let's just put some flux on it, and let's wick it a little bit, and pull the cap. And the holes should clean pretty easily. And we'll see if they even used the right cap. But you know, someone definitely knew what they were doing, right? Typically you don't run wires across the board unless you know what you're doing. But on the other hand, I've seen a lot in this business, and I've seen people not knowing what they're doing with pretty decent confidence in thinking that they know what they're doing. And that's even worse when you have incompetence and confidence at the same time. That's usually Dunning-Kruger effect when you're just starting. But this looks like someone actually did know what they were doing. Oh, okay, I see the cap already has, look at that. So this leaked already. And let's see what's left on the board. Yeah, so the cap, let's just puncture it and see if there's any liquid in there. But I would expect no. Yeah, it's bone dry. The cap is bone dry. This is 47 at 25, which is correct. But it kind of looks like it's the original cap. Maybe they just replaced it with the exact same one. It's very possible. But to dry to this point, like when was this done? Right? It must have been done like really long time ago for this cap to dry to this point. They normally don't get dry this quickly, this much. But if it is original cap, then I don't understand what was being done over here, you know? Why would you run those wires and stuff without replacing the caps? But the other cap has not been replaced for sure, because this is kind of an unusual cap as far as the color and size. I don't think you can get the exact same one nowadays. So, but that cap usually is not a big issue. I mean, I replace it since I already have the device on the bench. So I'll replace the cap. Yeah, I smell electrolyte burning. So, well, judging by what the cap looks like, then we don't even have to test it. Well, right now we can't even test it because it's damaged physically. But it is definitely dry. So that makes me suspicious, you know? The level of, it's basically what I see here. It makes me suspicious. That's why I could consider that the cap has not actually been replaced, but instead they just ran wires. So it's weird because, you see the corrosion on the board, but where did the corrosion come from, right? So if you just address the corrosion with with huge wires and stuff, then the problem is just going to propagate, essentially. You didn't fix anything. Look at all this green copper over here. This needs to be removed, otherwise it's just going to keep corroding. This via doesn't look too great. Oh my goodness. You know what, let's remove the film caps, because we're going to replace them anyways, and let's see underneath. Because it looks like, now it makes sense. I hope this isn't what I think it is, but what is possible, yeah, look at this cap. So what's possible is that the technician essentially removed those components so they're not in the way, so they can solder on those wires to the board and just replace the same components. So that cap that we just removed, right, the dry one, they removed the cap, they maybe cleaned the board or something, although it doesn't look like it. They soldered on some wires here and there and replaced the same components again. They put the old components back on the board, essentially, which would be crazy, but these caps, again, they have, nowadays, those film caps have different case, so they look different nowadays. So you can kind of tell when they were replaced. I'll show you the cap, the replacement cap, in a second. Let's get them out first. Yeah, it's definitely leaded solder on these. So, these caps have seen the soldering iron, sure, but these are original caps. I mean, I understand if you remove them from the circuit to test them, right, and they tested fine. For film caps, that is okay, right? I could agree with that. Although I replaced them anyways, right? It doesn't matter what they're reading. That's what the ECM is here for. It's for a rebuild. So you replace all the components, right? Everything that goes bad with time, you replace it. So, but with film caps, I could live with that. Oh, that's the wire. Okay. Okay. But not with electrolytic caps. No way. That's a big no-no. You don't replace, you don't put used electrolytic caps in the circuit ever, anywhere. Unless you're, even if you're doing some prototyping or something. Even then, I would advise against it, because you never know if the cap is not going to give you any issues when you're experimenting. Let's give it some hot air and let's push them out, because they're a little bit stuck. Yeah, they're stuck because that wire has been pushed over here like crazy. Okay, and this one, come on, get in there. like this, and this one should be easy. This one should just fall. And let's see what we have over here. Okay, one completely fell out, and this one, come on. Okay, so this wire has been wired directly to the injector. Okay, there's your problem, but what? Oh, okay. All right, so we see why this wire was there, but that's not how you fix it. So we have a wire from this diode, D107, or yeah, D107, and it connects here to restore this trace. That is not how you fixed it. And we have another wire over here, God knows why, because this trace looks okay. Why is this wire here? And this is just crazy. See if I had a little more adequate prices, right? Because this is flat fee, basically, what we're doing here. And sometimes it's an hour of work and you're done, and sometimes it's something like this. This wouldn't be bad if I just received it like this and just had to fix it, no problem. But since now I have to figure out all those weird connections over here and why they were made, not to mention any potential damage that could have been done to the ECM because of this, that takes more time. And why was this one connected here? Okay, so this was completely unnecessary here. Let's get some of this solder off the harness because it's not needed here. There's a little bit of melting to the harness, but that's what happens when you solder on here. That's why you don't solder on here. It's crazy. It doesn't look like the pin has shifted, so that's good. So this wire was just done because you see the trace going over here and it was going to here, right? It's not connected. It's not connected here, right? It's connected here. So the wire was going here, and I guess just for the fun of it, maybe, yeah, maybe it was just for the fun of it. The technician just went overboard with this. Or the car was complaining about misfires. That's, because this is the injector signals for 2 cylinders. They're in sync. So we have 2 injection signals, not 4, even though it's a 4-cylinder engine. Yeah, because it was definitely, yeah, unless it was bridged. No, there's no way it was bridged, right? No, it was definitely connected to this, and God only knows why. Oh, probably, okay, I think the via was broken. Yeah, see here? Yeah, the via is definitely faulty, but again, that's not how you fix it. That's not how you fix broken vias. You know, the worst part of it is that I was hoping this would be a quick one because I have a lot of other stuff to do. So I figured, yeah, let's quickly get this one done. But it's gonna be nothing close to a quick job. Let's get all this solder off. It's not quite off yet. Let's pull on the other side. There. And let's see. So we have crap load of vias to restore. We have crap load of testing that we got to do over here. Well, it's mainly just continuity testing on the multimeter. So it's not a huge deal. We kind of do it anyways in every case. But this one is special because it has been touched the wrong way. It was a bad touch. That's not how you touch ECMs. You know, in ECM work, you just have to, it's different than other kinds of electronics. Just like essentially any kind of work you do, it's especially prominent when people go from fixing laptops to fixing phones. And Jessa used to describe it as, you know, MacBooks are like dogs and iPhones are like cats. You know, you can be rough with the dog, but if you touch the cat the wrong way, it's gonna hiss at you, and it's not gonna be fun. And with ECMs, it's kind of similar. You just you work with these devices a little bit differently. So no, you don't restore traces by running huge steel wires. That's number one. I'm kind of thinking that I'll give it a buff first before I continue with this, because now I know what the wires were for, so I know what the problems were on the ECM, and I'm pretty sure this cap has not been replaced. Now with those film capacitors, so this is the old one that wasn't replaced, and you can tell by, you know, all this gunk on it and stuff, right? Potentially damaged, right? But even if you want to replace it, you're not going to find the exact same one. So this is the replacement, right? It's slightly, the size is slightly different, right? And you see that it's, I don't know, it's a different cap. I mean, it's the same cap, right? But it's different production, right? So you're not going to find the identical like this one, because they don't make them anymore. So you're going to find something like this, 680, right? So that's how you know that it has been replaced. If you don't see these, then no, they haven't been replaced. So definitely these have not been replaced, and this cap is suspicious to me. It kind of looks like it hasn't been replaced, because look at all that crustiness over here. It leaked years ago. It's bone dry. This hasn't been working. So I don't know how the car behaved, but I wouldn't expect it to run nicely, because this cap is here. And actually, let's do some continuity since we're already here. Let's see if this VIA is still working. It is, surprisingly. Surprisingly, the VIA is fine. Now let's see this guy. This VIA usually, and this VIA is gone. Yeah, the VIA is completely gone. This is very typical on these. That's why in some cases you just have to know where to look, right? It connects to the here, right, the top layer, but it doesn't connect. Oh no, now I just kind of moved it. Yeah, we're restoring it anyways. Now this looks like definitely it is not connected here. Yeah, that's why that big wire. But why was a wire over here? So probably if we connect here and to the other side, yeah. Okay, so the VIA is, yeah, so that's why this wire was here. So there's no connection between this and the other side, right? Here we have, but the VIA is gone, and it doesn't connect to the other side, and the other side connects to, I think, this transistor or this one, but one of those transistors, right? So these two transistors control the injectors. So one injector is here, the other injector is here. Yeah, a lot of crustiness over here, some broken vias all over the place. This is crazy bad. I've seen bad work, but this takes the #1 spot so far on how not to do it. Alright, first I gotta give it a buff, and then we're gonna speed up the footage and let's restore everything. But I gotta eat some breakfast first, because I wasn't expecting this. Alright, I was gonna speed up the footage, but the more I look in here, the worse it gets. Look at this. So this is the diode, right? Which does not connect to anything anymore. So this diode never worked. It's an important flyback diode over here. It needs to be here. So crazy. Whew. Well, that's the joy of having a flat fee for certain procedures. Some are super easy and you just make money like a breeze, and some are like this one, but look how shiny. Look, I love this conformal coating. It looks like new ECM when it comes out of my shop, both sides of course. Look at this shininess. But to remove old conformal coating, it actually takes more time than retrace some of these. It's crazy. But we have, so what do we have here? So this trace was damaged, unrepaired. This trace over here was damaged, unrepaired. So I'm not sure how did this machine even work. Now this one was repaired, but with the huge wire going all the way to the harness, so that's how it is repaired now. And this one, again, a huge wire going across the ECM. And there was a third wire, but I don't remember. Or no, was there only 2 wires? Or was it 3 wires? Well, doesn't matter. What is this? Oh, a little bit of, see the original conformal coating. Unfortunately, stuff like that will be left behind. It's very difficult to just clean it like completely. You know, I mean, you could keep it in the ultrasonic cleaner for 3 hours, sure, but then, you know, you might get the ECM from it without certain traces and stuff. So you don't want to overdo it. It is perfectly sealed. It looks perfectly fine. We have new cups. And everything looks good here, so this is good to go. I'm gonna let the conformal coating dry a little longer before I put it in the case. The case is straightened out. I think this should be good. It should be fine. And the one screw missing, unfortunately I don't have those screws to replace it, so it's still gonna have one screw missing, but it's not a big deal. This screw just holds the top, this thing, so it's not a problem. If one of these is missing, that's not ideal because it holds the board. The board should be held by 4 screws, so it's evenly held. But even that shouldn't really impact the performance. Maybe longevity, but not performance. Alrighty, well, this is how you not rebuild ECMs. I mean, I can show you how you not rebuild them because I didn't rebuild it that way, but it should look like this, not what you saw it before. So yeah, I always say it in every video, just you know, be mindful of who you're sending your device to, because there's a whole bunch of us incompetent folk. It did work though, right? I think. But I'm amazed that it worked without that diode and without that one trace. I don't know how, but I guess it did. Anyways, thank you guys very much for watching. I do appreciate you. And I shall see you guys in the next one.